Good evening, everyone. Good evening to all of you. I'm Upasna, and it gives me immense pleasure to welcome each one of you on behalf of ACODS. Today, Masterclass is by our industry experts. We have the privilege of hosting two distinguished professionals who have achieved remarkable feats in their respective fields. Our first industry expert is Mr. Devender Singh, principal data engineer with over 2 decades of expertise, having contributed significantly to companies like JP Morgan, American Express, Ericsson, TCS, HCL Tech, and not to forget second industry expert, Mr. Nitin Mahesh, Vice President of Technology with an impressive portfolio that includes American Express, Ericsson, Amdocs, and more. We are indeed fortunate to have such esteemed personalities to share their knowledge with us today. So let's make the most of this incredible opportunity. Welcome once again, and let's dive into a knowledge-rich session. Now, I am requesting to Mr. Devender Singh to enlighten everyone with his true knowledge.
Sorry, I was on mute. Hi, everyone. I am Devender Singh. As a person told that I have been working from last almost 20 years. I have worked extensively with a lot of product-based companies and the service-based company. If you talk about my experience, I have been extensively working in the data engineering side from last 8 to 9 years. I have built multiple data platforms for the batch and the streaming one. I implemented hundreds of use cases for the streaming platforms as well as for the batch and for the machine learning pipelines. These are the key highlights which we have. Before we start, I would like to understand the audience, that kind of experience you have, the degrees you have, so that we can address the audience accordingly. I will take a minute pause. I will request you to put in the chat that what kind of experience you have, and then let's begin after that. Okay, last 30 seconds. Good. Thank you. Thank you for your replying. So let's talk about first, before we talk about the data engineering, let's understand what is data, right? So the data refers to any information, the facts that can be stored and analyzed. It means any information which can be stored and we can process that information. That is a form of a data. Now, the data can be anything, right? It can be structured data, it can be non-structured data, it can be image, text, all those kind of a things comes in the form of a data only. Can anyone of you can guess that how much amount of the data gets generated every day? Let's take a 20 seconds. Okay, so let me answer it. So on a daily basis, as of 2023, 2.5 quintillion bytes of the data gets generated every day. That's a study done by an IBM. This is a huge amount of a data, and this includes the data which is coming from various social platforms like YouTube, Facebook, Insta. The huge amount of data gets also generated from an IoT devices. And there's a huge amount of data still which is unprocessed and untracked. Just like a flight tracking data is not trapped. When a flight takes off and it landed, between that it generates tons of the data which is still untapped. So you can consider that the amount of the data which getting generated every day, right? Now there's a study that done by the IDC and the Seagate, which tells that by 2025 we are going to generate 170 zettabytes of a data. Now you just can imagine that 1 zettabyte is equal to 1 trillion gigabytes of the data, right? What does it mean? It means that the tap and engineers to tap that data and generate a meaningful insight is only going to increase as that amount of data is expanding exponentially, right? So it's important for us to understand that where the industry is moving, where the career is moving, what change is coming into the industry, how the data is changing, how the data can be tapped. So if we talk about the data is a black gold for us today, right? So this is what the industry says. Now you just imagine that if you talk about just a YouTube, every single minute on a YouTube, 500 hours of the videos get uploaded. Now you can understand that how huge amount of the data it is, right? Now, what is the various form of the data? So we have the data which is generated by the social media platform, the content platform, e-commerce platform. The data can be structured, semi-structured, real-time, batch, images, videos, and whatnot, right? So it can be in the form of files, that is the non-structured data, right? Which is lying huge on the social media. There's a lot of website which contains a lot of text data. This is all unstructured data which still needs to be tapped. A lot of analysis can be done out of it. How and who can tap those data, right? Where the data engineering come into the picture? Let's look at that, right? What is data engineering? What all of you understand by the data engineering? Now this huge amount of data which getting generated every day, this data needs to be tapped. First thing, right? When the data is tapped, it means we have to collect the data from the various sources and we have to make that data in a usable form. What all includes that? So the data needs to be ingested, the data needs to be transformed, data needs to be stored in an optimized manner, data needs to be integrated with multiple sources so that we can generate meaningful insight. The quality of the data also plays a very important role when we start consuming those data. Another important aspect is the data governance. What is data governance? That the data which we are saying, is it properly governed or not? What does it mean? Just like your phone number and your email is called the secure data, which is called the PI data in terms of industry. So that data has to be masked, that cannot be shown to the end user directly, right? So there comes the data governance role. So all of these things which when combined builds a pipeline. So that pipeline can be batch, can be direct, and can be consumed by the data analytics platforms. A lot of things happens with that data. So data ingestion, you just assume, right? Let's say you are browsing a website. Okay, for example, google.com or let's say Facebook or whatever it is. So, or let's say you are on a credit card company website. Whatever page you are browsing, that generates a lot of click stream data as an example. So that data can be tapped in a real time to see and observe that what a user is doing on a website, and the respective things or offers or the bot can be empowered using those data to see, give the meaningful insight to the user in a real time. So that's how the data can empower. Data transformation. So those data, which is, I took an example of a click stream that coming in the form of a JSON or coming in the form of a raw data. So that data needs to be transformed in such a way that we can use that data effectively and we can transform into a meaningful way. Now, just assume that the amount of the data which gets generated every day. Amazon.com has a billion of hits every day. So you click on a website, a clickstream data is generated, goes into a messaging system in a real time, that gets stored into the storage warehouse. That's one example of it, right? So this amount of it's a billion of I think 5 to 6 billion events get generated by the Amazon every day. That data is huge. That goes into the petabytes every day. Similarly, just look at the YouTube I told you, right? Every single minute, 500 hours of the data generated every day. So that's the one copy of the data which user uploads. Now, as depending on your devices, like a mobile, laptop, TV, you have to generate multiple copies of the same data so that you can render the data effectively depending on the device you're logging. That's one aspect. Another aspect, have you guys observed that when you're watching a video, suddenly the picture gets blurred? Why that happens? Because of the internet speed, the video quality get reduced depending on your internet bandwidth and the speed. You have to render a video which is of a low quality so that the user is able to see the video. So that's kind of a deep and solid engineering goes behind the background, which the data engineer empowers. Data indication, right? Combining, have you seen that you log in into Google, you try to buy something and you keep seeing the same ads everywhere, irrespective of what website you log in, it still give you that. Let's say you're trying to buy a cloth or a shirt or a t-shirt, you will see there are a lot of ads coming on your every page, irrespective of what page you goes in. So those are the simple data integration points which the Google ad engine empowers to see that what are the user, what is your history, and what kind of interest you have, so that they show you the relevant ads. Another important aspect is the data quality. So let's say if an email ID does not have at the rate, it means it's not email. So those kind of data quality checks needs to be made and has to be done so that the data is accurate. Where this accuracy come into the picture, when your machine learning model or the data analytics platform uses that data, they can generate the meaningful insight from that data. And it's very, very important, right? So that's where the data engineering comes and plays a very important role. Now let's understand what does a data engineer do, right? So that's what we are interested in here. What is the role of a data engineer? What kind of a thing he does? The data is the center of the many challenges. Considering the amount of the data getting generated every day is huge, and data can be of many forms. It can be CSV, Excel, Parquet, JSON, video, images. Right now, you just imagine that how much data needs to be tapped and stored effectively so that you can utilize them in an optimal way. So big data platforms you need, just like in Hadoop, Spark, there are NoSQL database, there's a Redis database, there's a cloud technologies which we use by the cloud engineers. What is Redis? Just assume that Redis is an in-memory database where you can render the output very fast, right? So there's one more thing to save your data in an optimized way so that your data is saved in a manner that it can be rendered very fast. Let's take an example, right? Let's say everybody opens the Facebook as an example, right? So you have a timeline which gets rendered very quickly. How that gets rendered very quickly? You see that when you scroll that it gets loaded, right? What happening behind the background? The data which needs to be rendered to the user immediately, that goes and stored into the cache, right? So now consider the width of the data engineering platform. It's not only the data ingestion on and the transformation and how you do the data quality checks, it's also how you render the data effectively. That's also play a very important role. Apart from this, how you're going to build that data in a scalable form. The data is huge, right? What does it mean? If you don't process that data parallelly, we are not going to use it effectively. The amount of the data is huge. If you don't get that data, process them in a manner, in a speed, we will lose the ethics. We will lose the essence. Let's just assume that your YouTube videos just keep hovering, 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 hovering. You will lose interest if it keep hovering for 1 minute and then you shut it down. There is an instant happened on Amazon site, I think 5-6 months back, where there was a latency of 1 to 2 seconds on rendering the website. $35 million lost within 1 hour because of just slowness of the rendering of the data on the web page. That's the kind of impact makes when you're rendering the data on the website. Those pipeline has to be very fast. Who designed those pipelines? Data engineers. So that data, not only the storage, retrieval also plays a very important role. Now the data which you are storing, it should be used for the decision making, right? So the data should be decision making. All those aspects is being covered as the part of a data engineering. Is that only what data engineer does? No. Infrastructure management, right? That what kind of infrastructure you are going to use, what should the cluster size, how many nodes you need, all those things come into the picture in the mind. What should be the memory of the e-servers? What should be the memory of the Redis cluster? Let's say if the application is running, how much in memory it needs, how many physical memory it needs. All those kind of a decision is taken by the data engineers. Another important aspect where that this data is used, it is used into the machine learning. So the data preparation for a machine learning use cases is also an important aspect of the data engineers. So they need to understand the data very well. All this data needs to be used by machine learning models in a batch, in a real time. Both are the different aspects. So the data in both the cases has to be rendered differently and used differently. So that's all kind of engineering, and the thought process has to be put in by the data engineers. What is the responsibility of a data engineer, right? So the building the data pipelines. What is data pipeline? Tapping the data when it is rendered to the end stuff where it is stored or rendered by a platform which is for visualization or for rendering the offers. So this whole pipeline is built by the data engineers. So there's a lot of engineering goes behind this background, considering that, let's say you need to tap a data real time. Now there you need a latency only if 5 milliseconds as an example. So those pipeline has to be such an effective that you have not only ingesting the data, you are transforming the data, you're doing the data governance, data quality checks, you are integrating the data, and then you're finally putting into a system for the consumption. And all those things has to be happen in a millisecond. How does your warehouse look like, right? What is warehouse? The warehouse is where you store the data, right? So data engineers build and maintain those warehouses. Data lakes, feature stores are part of this, right? So where the data lakes and the feature store is used, machine learning models, other platforms uses those the refined data which goes into the data lakes and the feature stores. All those things has been built, managed, and maintained by the data engineers. When the data is stored, there's a compression which happens behind the background. So assuming that you are storing the 500 GBs of a data in a day, if you keep storing the data in a raw format, it will pile up, right? So that 500 GB of data when compressed, it can compress into a 50 GBs of the data, or maybe less, depending on what compression technology you use. So that's kind of a thought process a data engineer has to put in the solutioning when they're designing the architecture for this. We already talked about the data transformation and integration, which a data engineer does. Infrastructure management, security is also a very important aspect, that how the data engineer can collaborate with the data stewards. Who are the data stewards? Business people are normally the data stewards, where they define the compliance and the privacy, which used in the data governance policy and the regulation, which a data engineers collaborate with them and implement the required solution for that piece, right? I just briefly touch on that, how a data needs to be rendered in a milliseconds. That comes as a part of a performance optimization. What needs to go into the cache, what remains in a hard disk, what needs to be rendered real time, what can be fetched in a can be fetched in the batch form. All those informed decision has to be taken up by the data engineers only, right? Another important thing which data engineer does, they collaborate with the data scientists. So the data which we are generating as a data engineer, that is used by the data scientists. So that's where the important aspect comes into the picture. If you have a one data scientist, you will have a multiple data engineers to generate the data which is meaningful for them. As a data engineer, we has to be very skilled, right? So the continuous learning, because we all know that someday or other day some new platform comes, but the essence of the data engineering does not changes. So the essence of the data engineering always remains the same. It's just that the technology changes, right? That's what happens. So we have to be always innovative. We keep improvising the things which we have learned, and we also keep learning that what are the important aspects that we can incorporate as a data engineers in future. There's a lot of people think about that, what is the difference between a data engineer and a data scientist? That's an open question which hundreds of people search over the internet, over the web, right? So the data engineering is primarily focused on the development, maintenance of the data infrastructure system and processing the data. That's what the data engineer does. What is the other important thing data engineer does is how to get that data in an efficient, reliable, and a performance optimized way, so that we can store the data in such a way that we don't blast the warehouse, right? So it also has a cost associated with it. How this data has to be stored in a warehouse, which databases has to be used, which technology has to be used. This all informed decision is taken by the data engineers. data engineers should know the programming languages as well, right? Python, if you're Python program, in Java, you can use. If you're working on the Spark, you can use Scala, right? So that's the technology which you work upon. Right? So ETL is basic form of the data is extract, transform, and the load. Right? The data engineer is primarily responsible for designing and implementing the data architecture. With that said, it's not an easy, lot of complex engineering goes behind this. That's why the data engineer is one of the most high paid engineers in the industry today. Right? Now, what is data science? Power BI, Tableau, the data which is generated by the data engineers is used in a platform by the data scientists. That's just like a Power BI, Tableau, to generate the meaningful insight and the boards out of that data. Right? That's where the data scientist is involved. Where the places data scientist is involved in building the machine learning platforms. There where also the data scientist plays an important role. That the data which we have generated, how to explore that data, how to build a machine learning algorithm which can generate a meaning as scores for you, which can be used by your algorithm. Right? So here the Python and R is most widely used in the industries, right? So where the data scientists also come into the picture, right? Now, we have talked about so many things, right? So let's understand in a very basic layman language, what is a data engineer, what is a data scientist. Now you consider a Formula One car, right? So you have so many people works for a Formula One car, right? Somebody changing the tire, somebody is repairing the engine, right? Somebody is sitting on a driver's seat. So the person who's sitting on the driver's seat is a data scientist, and the people who are working around this, making those cars workable, changing the tires quickly, putting up a lot of engineering behind the background are the data engineers, right? So what does it mean? The data engineers demand will be always more than the data scientists, right? This is what it means for you. Now there will be continuous needs of growing the data engineers in the industry. Every company need the data engineer and the data scientists who are specialized in their work so that they can use the data effectively, right? That's where the role come into the picture for both of it. Now I will hand over to the Nitin Mahesh to give more insight, some on the big data side, and walk us through some architecture diagrams. Nitin, over to you.
Thank you, Devender. Am I audible?
Yeah, you can share your screen.
I can use the slide if it is possible.
Yeah, you can use it. Sorry, let's continue.
Yeah. Hello, everyone. Good morning and good evening. Welcome to this data engineering masterclass. Today is the start of an awesome journey into this world of data engineering. So my congrats to all of you for choosing this path. So data engineering, as Devender said, that is such a fascinating field, nowadays. Because of this technology-driven world, we have seen, how this chat GPT is growing, and we can see that data is so important nowadays. And we are blessed with, computer knowledge, and with this programming mindset, we can grow ourselves together and achieve so much in this, nascent stage. I can still say that it's still, at the nascent stage only. There are a lot of things we need, you and, everyone of us, we need to do and achieve. I encourage you all to be curious and ask questions. Let's make this session interactive. Okay. So now about me, I have more than 15 years of experience in development field across various domains like finance, telecom, credit card billing, and I have had the privilege of working on various complex data projects and designing and implementing cutting edge data solutions, that too at the very great enterprises. So throughout my career, I have honed my skills in data architecture, ETL processes, data modeling. I was also like freshers and had lateral experience like you guys. I was also curious about that, how this new fields are uh, getting emerging. And I mean, believe me, I mean, 10 years before, this was not that much easy. It was in 2012 when I read or heard about this term called big data, right? So this is what the slide is, I'm going to talk about. So let's start. So big data, this refers to the large and complex data set, right? That is beyond of traditional data processing, like tools like, RDBMS, SQL. So where, we require specialized technologies for storage, right? Processing that storage and analysis, like compute, like, because that is the data that have some kind of, knowledge inbuilt. How can you access that data? So all those things, as a, when you combine together, that is called the big data, right? So there are three main characteristics, nowadays people are saying four, but still I will go with that basic and original hypothesis is that volume, right? It's a huge data. I'm talking about, exabytes. As Devender mentioned, that we are going to generate exabytes of data. 10 years before, when somebody told us that petabyte of data, it was a fascinating numbers for us. Velocity, right? As we know that data is flowing so faster nowadays. We are expecting, millisecond of latency of processing, accessing. We know in the 4G, 5G world, we are already, thinking about 6G, how that data speed will come. People are showing the numbers, like you can download so many, full HD movies and 4K movies. All this is happening because there is a backend in the system, which is actually accessing you, providing you those things, infrastructure where you can get this data as soon as possible. And the variety, we are not limited to image, videos. There are, a lot of things, where the data is being generated, being captured, being, analyzed. So that is what the data is, right? That will change with this due course of time. So, and this is why the big data has, revolutionized this, all the industries, not just one particular industry, by enabling the, data-driven decision making, right? You are able to take, enterprises are they are able to take that decision. If I talk about from the credit card companies, you are swiping and let's say that there are some frauds are supposed to happen on that location. There are backend solutions are in place right now, which are doing this in millisecond and telling you that whether this merchant is having, some kind of goof up at the backend side so that your transaction can be fraud or not. And with this, we are able to uncovering valuable insights and a lot of, innovations we are able to drive. And that has a significant impact on business and society. You just think about, 10 years back when just, you wanted to open a bank account, you had to go to the bank and you had to do a lot of things. But now it's happening like within 5 minutes, you are able to open any particular, account using this, big data and the backend capabilities. So, Devender, can you move just one more slide? Next slide. Yeah, thank you. Yeah, so this is a small slide, but it has, a lot of meaning. That is why you all guys are here, right? This data, there are a lot of information is flowing with each and every platform, e-commerce, right? Social media, live streaming, video, Netflix, messaging, a lot of things are happening, and if you see this number, this is going to grow, right? And you have to, just go with this one, realize this, these numbers, and we have to work towards, to achieve and gather that information where we can enable such systems which can utilize this data, which is being generated each and every minute, and able to generate the insights for the, teams, for the enterprises, how you can make sure that here at the ACODS, I believe, the kind of course that which we have created, it will be, it will be an amazing opportunity for you guys, to get the knowledge of all those tools which can help you in order to process this data. So with that, I would like to give you, a small demo. Okay, yeah, sorry. So there is a data flow pipeline as well. So with this data flow pipeline, typically as a Data engineer, right? When I started as a data engineer, I was not aware of that, the whole process, how it was like that. I mean, because we were so much engrossed with the domain knowledge. But when this particular slide, I mean, if you take it as a, I mean, your, cheat sheet, you can say that. What is the data flow pipeline, right? There are a lot of things are happening. Forget about domain knowledge. First, you need to understand this pipeline, right? How the data is being captured. So for capturing, there are a lot of transformations are happening, right? Orchestrations layer, how the ETL processes are, happening and executing in this data. Ingestion, right? When you are doing ingestion of the data, you also you have to make sure that data is having some kind of cleaning is there, data cleaning could be there, right? Some kind of data quality also we need to generate, whether this data is accurate enough or not, whether to store, right? I mean, before storing, you have to analyze this data, right? And while you're storing this data, you have to have the governance in place, whether this data is PII data, security data, or is it public data, information data, right? A lot of things we need to take care of at the time of storing and making sure that access is controlled, okay? Now we need to compute. How are you going to compute? We are talking about a lot of feeds. We are talking about the data, which is huge, right? So there should be some kind of catalog around it, right? If you see that catalog is going to give you that information, that which data, which feed, which columns are there. Now, how are you going to use it? You have to process the data, make those reports available. And that way, this entire flow pipeline, you can think of, from the left side, your data is being generated and captured, and in the right side, your data is giving you the valuable insights. So that's the way this whole data flow pipeline for a data engineer is so much crucial, because the whole life of that data engineer is into these 4 or 5 phases only, where you have to plan it, work it, making sure that code is working, you are able to deploy it and test it, and able to fix all the production bugs. But yeah, this is the the slide which you would like to remember. Yeah, okay, thank you, Devender. Let me share my screen. Let me know if you are able to see my screen. Can anybody, Devender, can you please confirm whether you are able to see that?
Yeah, then I can see your screen.
Okay, perfect. Thank you, Devender. So here we are going to, just a small demo of the Python and the Spark. So first of all, I mean, let me talk about the Spark, right? Spark is a framework, right? Which is actually helping the enterprises and providing the power to execute the real time and the specialized data to actually you can compute that data, right? Real time, also in the macro batch framework as well, and also making sure that you are able to you know tapping the power of that true distributed compute, right? Where you're able to execute the data, the processing at the data, where the data is, distributed across all the various machines. Okay. So if you, I mean, I'll just take one, small an example from where the books, I mean, the New York Times bestseller book, let's say that as a data engineer, junior data engineer, okay, you are given a task that you have to analyze this data, and based upon that applications or that particular project, there is a data domain knowledge is required. So let's say that here I am a I have been given a task to analyze the data of the New York Times bestseller books, right? How I'm going to analyze it, I mean, what are the top books which are being sold, who's the top author, right? Are there any book sets which are matching with the other I mean the book names? There are a lot of insights which we need to generate, and you have to make sure that whenever this code is ready, you have to make this as a production ready. You have to deploy it into the production. I mean, there are a lot of scenarios, around that testing and deploying, but I will keep that, going to give you the demo of that, how this, you can run it. I believe that some of you already aware of Python, because this will, will need little bit of knowledge of the Python and the Spark as well. Here you can see that I'm using this Jupyter Notebook, highly recommended I mean, nowadays, anyone who is coming from data science or data engineering background, they are trying this out. I mean, for a whole, lot of applications are being created by using this tool. So as you can see that I'm just right now setting up some frameworks or, the Python modules. Now here I am, initializing the Spark session, right? So I'm just giving you, that how you can configure your Spark, applications as well, like, how many, executors you need and all those things you can define it here. I will show you, clearly. So this is what my, Spark session is created. So let's say if I would like to open this. Okay. So here you can see that this is my, Spark cluster, which is just now ran. I mean, there are no active jobs right now. There are no stages and there are no storage. And you can see that, these are the environments which are there and, executors and some of the other things. Like you can see that, this much, storage memory is there. And because right now we haven't ran any SQL, so this particular job is empty. So this will typically look like for, I mean, and this is again going to be useful for you in order to analyze how your job is running, right? You would like to optimize your job. I mean, a lot of things you have to do. Okay, so let's say that first you have got your JSON file, right? New York Times bestseller, and you would like to, read it, right? So Spark gives you this, I mean, native functionality where you can, consume a lot of type of various data, right? Because your data is, variety, right? Variety means like many type of structures, right? JSON, text, CSV, Parquet file, ORC. I mean, there are some, binary files which are coming from the financial world. Let's say Bloomberg file. There are a lot of, stock exchange files which they have their own type of, format. So those type of things which are being enabled, you can create your own format as well in order to read it. But for the demo purpose, we are using this JSON where I'm just, read it, and now this data is read and it's loaded into the data frame, which is the Spark data frame. I mean, just a little bit more about the Spark data frame. So, Spark gives you, I mean, you must have read about the Spark RDD, right? Resilient Distributed Data Set, right? That was in the, previous days of the Spark versions, but now they have moved to the data frame and data set. So our data set is which is more highly constrained, but in the Python world, mostly we are using the data frame. So which gives us the same type of leeway, where, just like the Python. So we are also getting those things. So here it is giving you the object of that, your file, where you can now do whatever you want to do with that file. So just let's say that for the starting, I want to see the top 10 records. Okay. So now it is going to show me. So now you saw that, screen was paused for a few, but now I will go to the Spark cluster. Here I will click on this. Now you can see that these are the jobs, right, which ran in the back of the Spark cluster. So Spark was able to execute this. It was able to read the data. It was able to process the data, and it is showing me the top 10 records of the file. Now you can see that these are the ID, product URL, bestseller dates, description, price, I mean the publishing date and who's the publisher, and the rank of that particular book in that week, right? I want to see much more, data, like how this data is, being stored, because this is what the data engineering is all about. You have to understand the data. You have to try to generate small, insights which will give you that, you have to, familiarize with the data, so that how many nulls are there, how, what is the type of the data, each and every column, you have to understand it, right? What type of data type is there, because then you have, you can create the programs where you're reading the file and also making sure that if these are the numbers or characters, strings, how we are going to, consume that data. So if you see that here, I'm trying to, generate the column names and their data type. Also, it is also going to, display the, data frame, details. It is also giving you the top 10 rows, some, first rows and the 5 rows. So these are the bunch of library functions which are already coming with your, Spark data frame library. If I run this, and if you see now, if I go into the, cluster, and if I see, and here all these jobs are running. So as you can see that these are the different jobs. So if you see the show string, head, first, so these are the name of the jobs, right? So first, take, describe, count. So all these jobs are running in the backend, and you can go and see that how that data is being, how many stages. Once you go through the Spark, detail session, you would be able to see a lot of things. Now here you can see that these are the details of the file, top 20 rows. Here it is a summary of the data frame. This is the logical plan. These are again, going to help you in order to understand that how this planning is happening, because there are a lot of backend functions are happening. The whole workflow is being created where how the file is going to be read, from which machine we need to get which type of data, how and where we are going to create a single layer which that API can read the data and show you, in this manner. So let's say that again, you saw that there are some, duplicate, whether you would like to, minimize your data, right? Because this data needs to be not only be to be saved, there are some, analytical functions which are going to read this data, because as part of the data engineer, you have to create that data pipeline, remember, which are going to be fed into the machine learning models. How that machine learning models are going to read that data, unless if that data is not clean. Let's say that there are, certain rows which are being, replicated across many blocks of the data. So you have to make sure that you are cleaning the data, right? So first of all, I am removing the data. Here you can see that again, Spark data frame library giving you the duplicates functionality, where it is going to show you that after the dropping, it is giving you the same data frame, and which is going to show you that what type of data is being dropped from this one. And I want to see, right, the whole entries of the others, right? So you can run this, data frame, select, function which are going to show you the only the other names. Let's say if you also want to see the other columns as well, like other title, rank, price. So you can see that Dean or Kunz, right? This is the title, odd hours. It was a rank 1. The price is $27, right? Now, let's say I want to see those titles where the book title is, odd hours, then I want to give them a number, right? And for all the other titles which are not having the odd hours or not matching the odd hours, I'm going to put that as a 1, right? So these things I can do it. This right now, you would see that, why we are doing this. But let's say in the machine learning pipeline, okay, machine learning pipeline, the jobs, they are not able to see what is the, string values are there. You have to process that data. You have to make sure that, you are able to generate other type of dependent, parameters. And you're also able to make sure that the values which are being generated as part of that value, the data, that is also, you can do the compute on top of it. So all these things are happening because of there is a data science engineer who has given you the steps that these are the things which you need to do in order to get your data clean. Now, same thing is happening with the, I mean, you want to do furthermore exploration that whether the data is there or not, right? I want to see that if, how many, titles are there which where the authors are John Sanford and Emily Griffin and all those, right? And I mean, there are a lot of, functions are there which are, being supported by the, Spark data frame library. The I mean one of the functions I would like to highlight is this is the SQL functionality as well. So I mean, around 5 years back they have implemented this the SQL thing so that the people can start using Spark SQL as well, and which gave us a lot of boost in various communities in order to use the Spark. So that gave us, because now you can write the RDB mesh type of SQL command. So I just wanted to, again, all these being I believe will be shared by by the team, and if anybody wants to see more details, you can find it. Now here I'm okay. So after this, there is one more. Where is that? Yeah, here it is. So this is the SQL command. So now you see, you can actually write the SQL command as it is. So what this particular SQL is going to give you, that it is going to give you the number of titles based upon their theme, right? Okay, like mystery, criminal, horror, right? So those are the themes. Now if you are not well versed with the Spark data frame, if you are not aware of a lot of the Spark functionalities, that's okay. You can write the SQL as well. Inbuilt, the Spark framework, they have their own mechanism, optimized way of calculating the best path in order to get the data from the each and every block where the data is being stored, and also making sure the plan is getting executed. So there is a Spark job manager is there, right, where my application is being controlled and it is given a task. All the executors are in the back end being ran. I didn't show you the actual. Now you see that whatever jobs which we ran, this whole pipeline is there. And because right now I am running this as a manually, right? Now just imagine this job is live in the production environment and there are some bugs, there are some processing, their job is taking a lot of time. How can you make sure that which step is taking time? You can you come here, you can see on the Spark cluster that which job is taking more time. You can go into much more detail, how many tasks are being executed, what is the memory is given to these ones. But these are the especially, for a data engineer, you don't you have to code whatever data science engineer has given you, but also you have to make sure that that code is production grade, that is optimized enough so that job can run, it can consume data where the petabyte data is being fed into your job. Now imagine how you are going to optimize it unless if you don't have any way to see your job. So this is the way that you can see your job, and this is the just a small demo of the Spark job and how you can run it. Okay, so Devender, I would can you please share the slide again, back again?
Yes, Nitin, give me a minute. Okay, so we'll take a couple of questions. You guys have questions before we just briefly talk about 5 minutes about the architecture diagram. The people are asking that, so is the combination of a data engineering plus data science is a deadly combination? Answer is yes, but there are specific positions only for the data engineers and there are specific positions for the data scientists, right? It's good to know both, but you cannot be master of both, right? So so the data engineers are more sought than the data scientists. So They can be, there are positions in the data scientist team for the data analytics, data scientists, and couple of more. Similarly, in the data engineering side also, you will see that there are multiple positions. So each work stream is a position itself and asked by in industry as a specialized position. We'll have those slides covered later on where you'll understand that what are the data engineering roles, how the jobs are, what are the salaries, what is the roadmap, right? How you can end up in getting the good data engineering jobs. All those things are covered later on. So we'll quickly cover in 5-10 minutes about the Instagram system design. We just give you a essence that the kind of a data get generated into the Instagrams where the all at all places the data engineering is used, and then you come to the your roadmap and other stuff. Nitin, yeah, over to you.
Sure. Thank you, Devender. So now we will just take one particular use case, so we all are aware of Instagram, our day-to-day. I don't think so that, I mean, every day we are seeing that we are opening, a lot of things are happening, not just following the leaders and, our friends and nears and dears and ones. So how in the back end, how it is all being, driven. Let's say, I mean, 10 years back, somebody came to you and they are saying you that, how that Instagram is, we are going to make that Instagram. So, Devender, can you please?
Oh, sorry.
Yes. Yeah. So let's say that you are given a task, you have to create the Instagram. There will be some functional requirements to that, right? So as a product manager, I would come to you and for the MVP release, I need to release this into 2-3 months. That's typically, I mean, we would be able to see, the requirements are coming and they would say that, okay, people should be able to post something, let's say image for the starting, then the video in the next phase. And other people who are following you, they should be able to like, they should be able to comment and add, and they should be able to share with other folks as well. Also, I should be able to add the friends. I should be able to see the user post profiles, and also I should be able to see the logs that how my, I mean, my activities are happening, how many posts I posted, and who actually followed me back, and who actually, I mean, not following me now. And I also should have some kind of timeline with me where whoever I am following, and let's say if I liked something and somebody has made that as a tag and to me, and I would like to see that as well on my timeline. So these are the functional parameter, functional requirements which you can think of at the very high level for for the Instagram type of application. Not just Instagram, there are many applications nowadays. So being a data engineer, let's say that you are a senior data engineer level now, okay, lead data engineer. I would give you that, the first thing that you have to figure it out, not only is the domain knowledge, you have to understand, are we expecting the scale? Yes, we are. So is it read heavy or is it write heavy? That is your first question, right? Now, all these rendering should be happening at the fast level. I mean, are you okay to wait for 2-3 seconds before your post is being loaded? No, you are not, right? So that should be fast, right? What are the access patterns to my data? How they are going to, open this? Is this web application? Is it mobile application? Or, I mean, or are there any other type of application? Like in case of Uber, there are, there is a driver, I mean, apps, there are, I mean, or rider app, there is an admin app. I mean, there are a lot of things are there where you want to make sure that access is being controlled and is happening from other way. So you have to ask those things. Again, availability. Are you okay to have your downtime? Like in the banks, like generally, I mean, people, they say that, okay, banks are, there is a maintenance window for 2-3 hours, banks are not going to available. Can you think of that Instagram saying you that for the next 2 hours, Instagram is not available? No, right? It should be 9999. I mean, there is some terminology of that 999. Oh, sorry, that I mean 59 availability. They are saying nowadays, Amazon, AWS, GCP. I mean, all they are saying that. Again, the latency lag and your that whatever processing is happening in the back end, it should be scalable. We are talking about 1 million, I mean, posts in a day, right? Let's say that you can ask such questions, right, at that time. So people can say that there are a lot of people are there, they are, uploading daily. You are uploading, let's say, 5 to 6, post, or let's say images, or let's say monthly 1,000 photographs you are uploading. And if you are a, pro, and if you're a professional, let's say as a normal user, I'm expecting, 10, 20 posts in a month. So there are a lot of calculations are there, but how can you do that? So that's the next slide. Devender, can you move to that? So yeah, so this is the crux of that, calculation that will give you some, numbers in your back of your mind, that, how this is being calculated, right? I can tell you that right now, that this comes under the capacity plan, planning. So in terms of capacity, you have to plan for the storage, you have to plan for the network bandwidth, right? How many resources, as I just now, shown you in the demo, there was a job, which is consuming the, resources, RAM, right, storage. What is the database capacity? Because all this information we need to store somewhere, how that data is going to be, saved. So all these capacity planning, we need to do it. In order to do that, after the technical requirements, these are the, calculation you need to do. So let's take an example, typically, let's say product manager says that, okay, we are expecting that we have a 1 billion users, and daily we are expecting 500 million users are coming online, right? And assuming 60 million users are posting their photos, and let's say there are professionals which are posting their videos, we are expecting 35 million videos. So if you see, after this calculation, I can say that one post of a photo could be 3 MB of size. Okay, now which means that if I am expecting 60 million photos daily and 5 MB across the 500 million users, so I can say that after this 150 MB is my maximum photo size. So on an average, each user sends 20 requests, right, per day to our service. So this is what the resource estimation. Okay, now after this, I need to multiply this resource numbers with my storage capability. How I am going to store and provide this bandwidth and the database where I'm going to store this data. So after this calculation, typically roughly it would come, you can do the math, but 460 million photos per day. And let's say for the minimum size of 3 MB, if you multiply this number, you would get 180 terabyte per day. So now you can imagine that 180 terabyte of data I am expecting into my system. Now videos, 35 million videos are coming daily, and each video we are expecting 150 of MB. You can again do the math, and it will come up approximately 5,000 terabyte, which is roughly 5 petabyte, right? But if you add both of these photos and videos, it would come 5,400 terabyte, which is around 5.5 approx petabytes. So for a year, because you are not going to enable this application for 1 month, 2 months, so for a year, if you do this math, which is 5,430 terabyte per day multiplied 365, it would come around, you can do this like what, 1.98 million terabyte, which is approx 2,000 petabyte. And if you convert it into what is that next number after the petabyte, I think that that is exabyte.
Correct.
So after this, yeah. So now this is a storage estimation. Now we need to the bandwidth, calculation as well. So which is the number of servers, how many queries we are going to handle, and how many servers should be there in order to serve those queries. So typically one particular server is having, let's say, 20 cores, and nowadays we are expecting more, because servers grade machines are there, so which have high throughput in order to serve the request. So now all these calculation will give you that, okay, I should have 1157 servers. Now this is just a small number right now. I'm expecting these are the old numbers, but nowadays it is increasing day by day. I mean, for the chat GPT, if you see that their servers cost was around $500 million. Now you can imagine, how it is going to be handled for the other type of applications. So
Yeah.
after this,
Yeah, sorry, Nitin. Guys, please keep asking your questions. At the end of the session, we will be very short of time. So I and Nitin will keep addressing your questions. Please keep posting your questions over the chat. Sorry, Nitin, please.
yeah, yeah. So Devender, just to, track, like how much time do we have?
I think
And
we have couple of
we have,
5-10 more minutes left. So we'll keep this architecture discussion short,
Mhm,
guys. We will
mhm.
be taking the separate architecture sessions for the guys who will be joining us in terms of their preparations going forward. The course has been designed in such a way that you are ready for the interview when the course is done. Most of the course is practical based, and we have made sure that you get enough hands-on, enough attention on the questions and the topics during the course of the discussion when we are teaching you specifically focus on the interviews, right? So I will jump to the next slide.
Yeah.
In 2 minutes, we'll cover the essence that where the actual the data engineering components are used. I will tell you that where the data science come into the picture, where the data engineering is used, and then we'll jump onto the other slides which we'll be interested in, right? Yeah, Nitin.
Yeah. So this is the, typically low level, coming from the, after that, whatever that, resource numbers which we have now, the connecting the dots, how that my data will flow. So if you see from the left side, I should have the services available where I'm able to add the post, right? And I should be able to see the other users profile as well. I should be able to see my timelines. So, and this data is, being fed from the, web app and mobile app to my internal backend services where my, assets are being controlled, where I'm, able to store the metadata in the Cassandra, but the actual data is being stored into the CDN and Amazon, S3. And also there is a, ingestion service in place whenever I'm uploading something which is being used in order to save the, details into my metadata, database, which is the Cassandra, because of the NoSQL aspects are there. Again, we will have a separate discussion on that as well, how we can do that, data modeling and the timeline service. So we are in a way, this is the, microservices based, architecture where the data engineering is not that much involved, but you should be aware of that where this data is going to be used. So there are various applications, not only just ingestion, but the machine learning pipeline as well. On the top right, if you see that machine learning pipeline is there, there is a feature stored which is running, which is enabled on the Hadoop framework. So that data is going to be processed by using, let's say, Apache Spark streaming process, or let's say microbatch framework. So all this data which is being ingested into the Cassandra, and metadata which we are generating is being fed from there to the Kafka layer. From the Kafka layer, my Spark streaming jobs are listening to those my topics, and I am able to follow the same steps which we saw, similar to those type of demo, and you are able to create the data insights and storing into the Hadoop ecosystem where my feature stores are enabling and providing that access to the machine learning pipeline, and my data is being stored. So again, in a gist, you have to be, as a data engineer, you should know everything, but you have, your main job starts once my data lands, and in a format, how it is going to be land, how are you going to process it, all the steps, how can you make that, optimized for a big data. So that's what your task should be. So that's the way that your design will happen. So with that, I'm done. If anyone have any questions, I can take it right now, or we can do that separate Q&A session. Over to you, Devender.
Yeah, please keep posting your questions. Thank you so much, Nitin. Okay, so where does the future of a data engineer lies, right? So the people are required to build the automated data pipelines for the real-time processing for the batch. When we talk about the cloud, right, the serverless architecture come into the picture. It's good to know the cloud, but if you don't know the concept, you don't know how to apply those basic rules for the data engineering, big data, which can be applied over the cloud. Eventually, you have to write a Spark job, which even you have to run on a serverless architecture. If you're using AWS, you have to connect, let's say, if you have one warehouse, you can use the Kafka, or the warehouse can have a connectivity with a Confident Kafka. So you should know that how to connect with the Confident Kafka. Is that easy? No. So you have to performance tune the parameters for the Kafka to make sure that what is the input take, what is the output take, how does the Kafka throughput is to be managed, how the checkpointing needs to be implemented into the Kafka, so that you manage and maintain the failovers, right? So all those are the aspect which a data engineer should cover. So your governance and the security. So each of these work stream has a separate job within itself. So there are people who know Spark, know SQL, streaming platform, and plus cloud, one even of the cloud, they are very high in demand. So your 90% of the job gets covered there. Now people ask for the MongoDB engineer, those are the different aspects, the specialized thing which ask for the in the data engineer, those are different aspects, right? So those are the 10% of the jobs. 90% of the job is covered within this, right? So that's where the interest lies. If you talk in terms of a job, even this recession, right, you have a plenty of the data engineering jobs over the web in the company up to the experience of 15, 16 years, right? So I still in our inbox, there will be plenty of jobs. So that's how the data engineering is in demand. It's only going to increase, guys, to be that, because the data is increasing, so the data engineering jobs will increase. Now, if you talk about the roadmap, right? So what people should know, they should know the one language, programming language. It can be Python, Java, Scala. Python is the most preferred one. You should know the SQL, database management. You should know how the data storage and the processing works, right? Which includes any NoSQL database or any of the cloud storage platforms. Big data technologies like a Spark, Hadoop, any one of them you should know very clearly. So Spark is the most high demanded one. So that's, I think, widely accepted in the industry. You should know for sure the Spark, right? Data modeling, the design is a part of your uh, daily routine, right? When you are a data engineer, something or other thing has to be come up and optimized way in a manner that the data modeling will be done in on day-to-day basis, right? ETL pipeline, we already touched base previously that what it is. You have to do the data pipeline in the workflow management. So over the cloud, you use the Airflow. If you have your in-house cluster, you use Uzi. There are other also workflow management tool which has to be integrated with the data pipeline. What does it mean? Let's say you have to run a job at a particular time in 24 hours, right? So where does the Airflow come into the picture? Let's say after the job, you have to call a machine learning model in your pipeline, right? So there where the workflow management come into the picture. You should know one workflow management tool that suffice your need. Cloud computing, you should know one cloud on the data engineering for sure, right? So we are going to cover the Azure in an extensive way, and we also going to give you the essence of the AWS as well. Data quality and governance, there are the tools like OWL, which can be used for the data quality, and you can implement the data quality rules within your job itself, right? So those things can be embedded as a part of your data pipeline. Data visualization is the end goal. When the data is processed and put into a refined format, there comes a data visualization into picture where you use the Power BI, Tableau, or Python libraries like MATLAB, Seaborn, etc., right? To generate the meaningful insight from the data which you have generated. If you talk about the interview process, it depends on company to company. You are giving the interviews in a service-based company or a product-based company, but at the most of the time, you will be asked about the data engineering problem, basic concept of the data engineering, deep in the Spark, depending on which company you are giving interviews. If you're giving interviews in a product-based company, they are going to ask extensively. There are multiple rounds on the data engineering. There can be some rounds on the data structure, depending on Google, Amazon, whomsoever you're getting the interview. But most of the company on the product side, for the data engineer and the data engineering manager, seeks the data engineering information. SQL query should be strong, Spark should be strong, basic fundamentals should be strong, one NoSQL should be strong. So this covers most of your things on the interview process. System design should be very strong for the people above 6 years experience. So those are the aspects which people look forward for you, that how you can design a scalable data engineering application, how the Google engine or search engine works as an example, how the uh, Instagram work, how the YouTube works. Those kind of interview questions will come during a system design. If you are well aware with the basic concept of the system design and the data engineering, you are good there. So a lot of people ask on the other chat, right? What is the data engineering, data science? Most of the data science part, scientist part goes into the training the data, retraining the data, right? So that's 80 and 90% of his job. 15 to 20% time goes on building the machine learning models, right? So you can understand the the role which a data engineer does for this pipeline is huge. So the pyramid and the number of jobs are similarly in this manner goes what you see in the pyramid, right? So data engineers will always be more in number than the data scientists, right? So data engineer primarily is responsible for building the pipelines, cleaning the data, giving the right data to the data analyst, right? So the data scientist and the data analyst, basically data analytics are used for generating the meaning info, insight and the dashboard. What are the ML engineers? And those are the core engineers which build the AI and the deep learning algorithms. As an example, face recognition system, right? Those are the things which ML engineer does. This is very high level about it, right? And now let's see this is a study done by I forgot the company name, but they have figured out that the data engineer jobs since 2022, right, is growing 50% exponentially. That's how this boom came up since 2020, because the data is increasing. The more AI needs grows, more data engineer needs grows. This is how exponentially it is, right? They are interrelated to each other. They are not different. If one AI job, two data engineer jobs, three data engineer jobs, that if those grows, this will grow exponentially by itself. Here you go. In terms of salary, these are the aspect of a service-based industry which are common across the industry. The junior data engineer salaries goes from 5.5 to 10 depending on your experience and your current package. Then you have associate data engineer salaries can range from 50 to 20, senior data engineer 25 to 35. The senior data engineer which you see here in a service-based company, this 35 can become 65 in a product-based company like Amazon, Google, Expedia. That all depends on your skill set and your profile on a product-based company. Okay. Product manager or data engineering manager, right? So if it talks 40 LPA here, this can go to 1 CR in Amazon, Expedia, Walmart, those kind of product-based company, right? If you go to Cognizant, if you go to American Express, if you go to JP Morgan Chase, all those kind of companies, right? This lies between 30 to 50. The lead data engineer also lies within the same range. In the director and a VP, right? So there are multiple roles, technical and the non-technical, right? So you can go to the manager rank, which is the data engineering manager, which is combination of both. Those are also high paid salaries. You can go as a principal engineer. So I'm a principal engineer, right? So the principal engineer salary will be more than the data engineer, but the data engineering manager are equally well paid, right? And they're also high demand in industry. Now I will leave it to the ACOD teams to talk about ACODs and the course structure. Upasna? Upasna, you're on mute. Anybody from ACODs team?
Hello.
Yeah, we can hear you now.
Yes. So till now, you all must have got a lot of knowledge with Devender sir and Nitin sir. So now, as you know so much about data engineering course, so I just wanted to tell you that who's eligible for this course. First of all, you should be either have done MTech, BTech, MCA, or BCA with at least 60% graduation marks. And then data engineering is designed by industry experts, certified by our CPD UK body, which is an international certification. And it's a one-to-one mentorship will be provided to you. Also, system design is taught, like big companies, we have Facebook, Amazon, all these companies want people who are good at system design. Then coming back to the placement part, it's 100% placement assistance you'll be getting. And if I talk about duration of the course, it's 100% placement assistant, and it's 7 to 9 months duration course, and course fee is 1,75,000 with you'll be getting 20 to 30% scholarship, and also 100% loan you can avail with 0% interest EMI. So if you register today, so the fees will be 1 lakh, which will be very nominal for you. And then if I talk about like when your 75 to 80% course will be completed, interviews will start, and in between you will also be getting expert sessions. And definitely regarding the curriculum part, uh, definitely we'll be sharing you everything. Curriculum, we'll be sharing the link. Also you can contact me, we'll share you all those details soon.
Yeah,
So
I,
thank you
yeah,
for your time.
yeah, I just want
Thank
to
you so
add that.
much.
I just want to add that for this program, you have one-to-one mentorship session. You will get separate design discussion sessions for this one to groom you up, and you will have 2 to 3 mock rounds of the interviews with the expert, so that you are pretty much groomed up on all the aspects. And you will get a dedicated mentor also in case of any doubts. This all will be the highlight of this program. Thank you. Anything else, guys? See questions here. Okay, so I am not good at propagating understanding basic. Is big data good for me? Yes, if you are ready to learn a programming language, you can be a good data engineer. Okay. Another question is that can an airflow and a control M after the development in a QC environment, we can use airflow? I don't know if it's a question or it's an answer, but we can take it offline. You can post the question to our counselor. We can get back to you on this. Please move quickly to the roadmap and course. We already explained you on this. You done MSc in physics. I am not sure, man. But there are companies, if you are good into the data engineering, you should be able to crack that. It's just that you must be working professional on the engineering side. If you have that experience, I think then your designation MSc physics will not matter. Okay. Anybody has question? आप हिंदी में पूछना चाहते हैं तो आई थिंक यू कैन काउंसलर से आप लोग 1-on-1 सेशन कर सकते हैं या उन्हें कॉल कर सकते हैं ऑन अकॉर्ड्स की साइट पे. You can get the details. आपको यहाँ पे details मिल जाएंगी if you want details, and you can have a common discussions with our counselors. You can note it down. We are going to cover the Azure in terms of a cloud technology. That's what is it. Some people are saying fees is too high. We are going to provide the 100% placement assistant, and this whole program will be 100% funded by the bank with no interest charge. Any other question, guys? You can post it over the link. If no, you can have the contact information. You can reach out to the ACODS people and they can assist you better. Thank you. With this, we will end our session. Anything else? Yes, it will be converted to EMI 1 year. Depends on you. 6 months, 9 months, 12 months. All those information you can get from our counselor. They will be able to assist you and help you. You will just need to give the minimum documents to them, and everything will be taken care. Okay, with that, I will end the session. Thank you so much for taking out your time and joining the session. It was nice interacting with you guys.
Thank you and best of luck.
Thank you. Bye. Bye, guys. Bye.